Here's the story, and it's way more subtle than it sounds. A previous paper argued that you can get a positive event study curve even if LLMs do nothing. The mechanism is a stopping time selection. Think of it like a smoke alarm. If you define the day the alarm first rings as the start of the incident, then you'll always see a spike after that day, even if the incident is just random noise. RBB's claim was, quote, "The detector flags an author's first month as LLM adoption, and that timing rule alone can manufacture the pattern." Sounds plausible, right? But this new paper tests whether that artifact can actually explain the size of the observed productivity bump. First, they question the logic of a matching placebo. RBB used random placebo flags that are uninformative, then said if you still see the same post-treatment path, the artifact must be the whole story. But matching the shape doesn't prove null. If LLM adoption truly increases output, then any output-tied marker, even a random one, can accidentally line up with the real surge month. The placebo then traces the real effect, not because the detector is informative, but because the surge makes almost any flag look time-aligned. Second, they show contamination in the data. Because both the detector and the placebo flags rise with output, high-output authors get over-selected into the placebo group, so the placebo doesn't isolate the pure stopping time artifact. It's conservative, yes, but it's also not clean. Then comes the key move. RBB said the artifact size depends only on the detector's flag rate, so the authors don't just compare to a random flag at some arbitrary setting. They lock the flag rate to the detector's realized rate and use that as a benchmark. They find the detector signal stays well above what stopping time selection alone could produce. Finally, they run multiple redesigns where the timing artifact can't bias the estimate. Before-after with separated years, conservative difference in differences controls, an intensity model that never defines an adoption date, and a rank-based approach holding the flag rate fixed. The positive productivity association persists across all of them, while the same tests on pre-ChatGPT placebo periods return null. So what's the verdict? Yes, the artifact exists, but it's bounded, and it doesn't account for the pattern we see. If you care about whether this research pipeline is causal or just coincidence, subscribe and drop a comment. Which part surprised you more? The placebo contamination or the rate matching fix?